In our previous videos, we explained how vector databases store meaning and how RAG grounds LLM reasoning in your organizational knowledge. But what happens when the model needs fresh information such as real-time data or up-to-date dashboards or numerical computations or maybe domain-specific logic? Today's foundational concept, MCP, enables your AI to go beyond static knowledge and align with real-world systems. Welcome to Careerlink, your hub for building and applying AI in the real world. In today's video, we're gonna discuss the importance of MCP, Model Context Protocol, and this video is intended for organizational leaders as well as working professionals. Now let's return to the enterprise scenario we have been using. An employee asks, I work remotely, can I afford a $1,200 monitor? Using RAG and LLM and a vector database, we provide the correct policy answer. But now the employee asks, how much of my remaining office budget do I have left this year? And we can't have a proper answer for this question. This is not a policy lookup. It requires fresh data, numerical calculation, business logic, possibly cross-system data as well. A vector database cannot provide recency or compute logic. An LLM cannot access your internal ERP system in real time. It only reasons on what it knows. There is a gap. How does the model get up-to-date data and perform domain logic? That gap is what the MCP tools solve. The problem before the MCP. Before MCP, developers attempted embedding real data directly into prompts, hard-coding API calls into prompt templates, building ad hoc tool call logic, and this approach caused several issues such as LLM hallucinations about API, inconsistent outputs, no structured protocol for reasoning, and difficulty scaling to multiple tools or data sources. So, what exactly is MCP? MCP stands for Model Context Protocol. It's a structured specification that allows discovery of tools, declarative understanding of capabilities, safe and consistent invocation, as well as structured output interpretation. It transforms a loose LLM prompt into a typed interaction with external functionality. You can think of MCP as a contract between the model and the surrounding system. So the model doesn't guess how to use tools. It understands them through a defined structure. But what are the core values MCP adds? First one, real-time and recency access. LLMs have static knowledge due to training cutoffs. Business data is dynamic. For example, headcount, budgets, ticket systems, sales pipelines, and inventory. MCP tools allow the model to request fresh data from live systems in a structured and efficient way. The second value MCP adds is specialized skill access. Some operations are pure reasoning and suitable for LLMs. Others require precise computation, such as financial formulas, statistical metrics, risk scores, and date calculations. In such cases, MCP becomes a really valuable asset. Now, let's visualize both the examples that we talked about. First example, the user asks, "What's my remaining office budget this quarter?" The MCP tool is defined in our pipeline as follows: tool, input, output. The model knows the tool exists and receives a structured output. It doesn't imagine or guess the answer. This is fundamentally different from prompting the model to estimate or fabricate. Similar case in here. The user asks, "What's my year-to-date spend variance compared to last year?" An LLM cannot reliably compute this for arbitrary datasets and periods. Therefore, we use the MCP tool with tool, input, output. The model invokes the tool, receives computed results, and then formats the response. You have now extended the AI with real-time logic and computation capability. But how does MCP work? At a high level, MCP involves 4 steps. First, tool metadata definition. Each tool describes name, purpose, input schema, output schema, constraints, and guardrails. This allows the model to reason about tool's capability. Second one, discovery. When a user query implies fresh data or computation, the model identifies which tool is appropriate, similar to how a developer selects an API after reading documentation. The third one, structured invocation. The LLM produces a structured call, such as tool arguments, user ID, and period. There are no hallucinated URLs or fabricated endpoints. And the fourth one, safe execution and output. The execution layer validates arguments, enforces permissions, executes the tool logic, returns structured output. The LLM then converts that structured output into a natural language answer. But why does structure matter? Without a protocol, the model guesses API paths, prompts become brittle, scaling beyond few tools becomes difficult, the system becomes unpredictable. With MCP, the model works with typed capabilities, error handling becomes systematic, developers can add new tools safely, policies and permissions are enforced. This structure is essential for production-grade AI systems. So, what are the strategic takeaways for leaders? Making MCP foundational provides recency and reliability, domain accuracy, safer interactions, and foundation for agentic systems. We'll cover the last point in our next video as well, so please make sure to check it out. Here is the final summary. Your vector database provides meaning. Your RAG system grounds truth. Your LLM reasons. And MCP tools provide access to systems that deliver current data, specialized logic, computation, and safe interfaces. Without MCP, AI remains intelligent but limited to static reasoning. With MCP, AI becomes reliable, extensible, and aligned with real-world systems. Subscribe to our channel and explore the MCP examples and code templates linked below. Also, make sure to visit our website and join our upcoming circle on RAG. The link is provided in the description as well. That's all for today. Visit Careerlink.ai for more information on AI circles. Furthermore, if you wish to explore all the previous foundational videos on how AI systems work in real-world scenario, I have dropped the links in the description as well, and make sure to check them out to clear your understanding on the basic concepts of AI foundations. Thank you so much, and thank you for watching.